So here, this is our highlight. When you have modulus x and x outside the modulus, so you need to check the answer. So here we need to check. Okay, I think I still want to use this page. Okay, because like we have a small things. So let's I draw the the stair here. Okay. Alright. So let's see the form 3. Our 3 here, we have modulus ax plus b, modulus cx plus d. Okay, you have modulus both sides. Okay, here I would like to recall back our properties. We know that modulus a is equal to sed a square. Okay, so we will use this on our form of absolute equation. Because you have modulus on both sides, you may change it into, you have ax plus b here, you have cx plus d there. Your modulus we change into sed square and sed square, and then you solve your equations. Alright, and the last one we have number 4. Form number 4, we have modulus ax square plus bx plus c equal to d. So it is just the same as before, we just separate it into 2 parts, equal to d, but with the symbol union, or because it is absolute. Alright, negative d, and you just solve your answer. Our final answer, you can write it in the form of a solution set, because we don't have interval. Okay, you can't use interval form because we don't have the interval here, because it is absolute equation. Okay, when it is absolute equation, it plays with the value. Okay, so I think later I will put some example for form number 3. Okay, so we stop here for time being. Okay, alright guys, continue with still in 2.2. Alright, absolute values, how we can solve the absolute equations. So absolute means the symbol equation is this one. So usually the equation will come into 4 forms. Alright, we go to the number 1. Directly you can just divide it into 2, equal to c or equal to negative c. Remember to use or, okay, for absolute equation. So the second one, number 2, positive on the left or negative on the right. Positive here, negative here. That's what I mean. Okay, next I would like to explain the number 3. You have modulus everything on the left and on the right. Okay, here I would like to go back to our definition. We have modulus a is equal to sed a square. So here we will use this to calculate, to solve this question. So we change everything by using this definition. So it is equal to ax plus b square sed equal to cx plus d square sed. Okay, that's how we are going to change. Alright, so for you to be clear about it, let me give you an example for this one. You have modulus 2x plus 1 equal to modulus x minus 3. So everything lies inside the modulus. So we change the definition by changing it to x plus 1 square equal to modulus x minus 3 square. So guys, what are you going to do is actually you square both sides. Why do we square both sides? Because we want to cancel the sed and square. Sed and square. So end up your equation will have bracket 2x plus 1 square equal to bracket x minus 3 square. okay, because these two has been cancelled with each other. Alright, so what is your job? It's actually to expand for this one. Alright, so you will have 4x squared plus 4x plus 1, x squared minus 6x plus 9. So let's rearrange them to the left hand side, all of them. So you will end up getting 3x squared plus 10x minus 8 equal to 0. So can we factor? Okay, so you will get 3x minus 2, x plus 4. So x equal to 2 over 3, x equal to negative 4. So our final answer should be written in this form as negative 4, 2 over 3. We start with the lowest to highest value. Alright, so that's how you solve the equation that have all modulus inside. Okay, so nothing left for you to do for this part. For form number 3, and we have form number 4, so you just rearrange them to positive or negative. Okay, as a highlight, guys, if you can see, anything that you have to put as positive and negative, you need to use or in between, the symbol or. And what another thing that I'm missing here, for form number 2, you need to check, because we have x inside modulus and x outside modulus, like the example I showed before. So remember, you have to check, okay, because we doesn't know that whether you can accept both answer or not. So I think that's all for our solving absolute equations. Alright, so see you guys on the next video.